If you are pouring concrete but skipping these 3 tests, you are risking the entire structure. But why are cube, slump, and temperature tests so critical? And what can go horribly wrong if you ignore them? Stick with me, I'll break it down fast and simple, and I will ask you a question that even many site engineers get wrong. Let's begin with a question. What's more important, the strength of concrete or how it flows during pouring? Tough one, right? You will find the answer when we talk about the slump test in 30 seconds. But first, here are the 3 essential tests every civil engineer must know. Cube test, slump test, temperature test. You would be surprised how many projects failed just because one of these was skipped. Let's start with the cube test. What if I told you a cube of 15 cm could decide if a building stands or collapses? Cube test is done by casting concrete cubes, usually 115 to 115 to 150 mm, curing them and testing them in a compression machine at 7 and 28 days. Why 28 days? You guessed it, that's when concrete reaches its characteristic strength. Here is your test. If the cube fails at 28 days, can the concrete in the structure still be safe? Think about it, the answers coming, but let's jump to the slump test first. Now the slump test, the easiest to perform but most misunderstood. You have seen site workers pour concrete into a cone, lift it and measure the slump, but did you know a perfect slump value doesn't exist? It depends entirely on the type of work. Columns needs lower slump, slabs needs higher slump. Here is your next challenge. Can you increase slump just by adding water? Sounds simple, but the consequences might destroy your cube test results. Let's connect the dots in a second. Third, the temperature test. You would probably thinking, concrete doesn't get fever, right? But temperature above 32 degrees Celsius, 90 degrees Fahrenheit during casting can cause early setting, lower strength, and even cracks. That's why site engineers always check the temperature of fresh concrete, especially in the hot regions. Here is another question for you. If concrete arrives at the site and the temperature is 35 degrees Celsius, can you still pour it? What should you do? Hold that thought. Now let's answer those questions. Can concrete be safe if the cube test fails? Maybe if a core test or NTD proves the actual structure is fine, but it's a risk. Can you increase slump by adding water? Yes, but that reduces strength, and your cube test will fail. Better use plasticizers. Concrete at 35 degrees Celsius. You need retarders or cold mixing water, or even delay the casting, otherwise cracks and shrinkage are guaranteed. Every test is connected. That's why good engineers doesn't just pour concrete, they understand it. Next week, inshallah, we will talk about a test that most engineers skip, but it could save you from major project delays. Subscribe if you want to level up your civil knowledge. No boring lectures, just straight facts, and tell me in the comments, which of these 3 tests do you think is the most ignored on site?